Let's be real for a second. Your development teams are already using AI coding assistants. It's happening right now. And while they're definitely boosting productivity, they're also quietly opening up a pretty significant new risk. So in this explainer, we're going to break down why AI-generated code is so often insecure. But more importantly, we'll give you a practical, technical defense guide for your organization. Let's dive in.
If there's one thing you take away from this, let it be this idea right here. Think of tools like GitHub Copilot not as some kind of all-knowing oracle, but as an incredibly fast junior developer. They're super fluent, they've seen pretty much every piece of public code on the internet, but they have absolutely zero experience or critical judgment. They can't tell a good, secure pattern from a bad one that just happens to work. And look, this isn't just some theory. This is a real, measured problem. Major studies from places like Stanford and NYU have put a hard number on it. Around 40% of the code that these assistants spit out has some kind of security vulnerability. Just think about that for a second. That's a huge number, and it represents a massive, quantifiable risk that we, as security leaders, have to get a handle on, like yesterday.
So let's really dig into that fast junior developer idea. See, the AI's #1 goal is just to give you code that works. Code that does the thing you asked it to do. It's optimized purely for functionality and speed, not security. It has no concept of context, or threat models, or trust boundaries. And that right there, that's the fundamental disconnect we have to solve for.
Okay, so if we're going to build a solid defense, we have to understand why this is happening in the first place. This isn't just a simple bug in the system. Nope, it's actually a core feature of how these large language models are built and trained. And it really all comes down to 4 main reasons.
So here they are, the 4 root causes. First, the AI is trained on vulnerable data. It's just a giant mashup of good code and really, really bad code from public repos. Second, it has zero security context. It doesn't know if an input is coming from a trusted admin or a malicious attacker. Third, like we said, it's built for function, not for safety. And last, and this is a big one, it's just a pattern matcher. So if an insecure pattern is super common online, guess what? That's what it's going to reproduce for you. All right, so now we know why this is a problem. Let's switch gears and talk about what the problem actually looks like. What are the specific vulnerabilities we should be on the lookout for? And maybe just as important, what's the big myth floating around that could be giving your organization a totally false sense of security?
Honestly, the list of flaws here shouldn't surprise anyone. It reads just like an OWASP top 10 list, because that's exactly what's all over the training data. We are seeing tons of injection flaws, especially SQL injection, where the AI just loves insecure string building. We see hard-coded credentials, weak authentication logic, and, oh boy, an almost total lack of proper input validation. These are the classics, and now they're being generated at machine speed. Now, let's talk about this myth, because it's a critical one that a lot of leaders fall for. The thinking goes, hey, we pay for the enterprise version, so we must be secure. Wrong. Enterprise features are all about data privacy and compliance. They make sure your code isn't used to train the model later on. What they do not do is change the fundamental security quality of the code the AI generates. The underlying model's the same, and that insecure training data is the same. So what do we do about all this? Banning these tools is not the answer. The productivity gains are just too massive. The real answer is to wrap these tools in a smart, multi-layered defense strategy. This framework gives you a clear, manageable way to get this new risk under control.
Layer 1 is our automated safety net. This is all about using the static application security testing, or SAST, tools you probably already have. The trick is to shift left, push these scans as early as possible, get them right into the developer's IDE so they get instant feedback. And of course, a full scan has to be a mandatory, non-negotiable gate in your CI/CD pipeline. Nothing gets deployed without passing that check.
Automation is essential, but it will never be enough. That's where Layer 2, the human element, comes in. Your code reviews can't just be about style or if the feature works anymore. Security has to be an explicit, required part of every single review. A really great practice here is to have your developers flag which parts of their code were generated by AI. That's a signal to the reviewer that this section needs extra suspicion and a much closer look.
Layer 3 is where we get proactive. We can actually improve the security of the code the AI writes by changing how we ask for it. This is called secure prompt engineering. It really just means training your developers to include security rules right in their prompts. Things like, write this SQL query using parameterized queries, or make sure all user input is validated.
You can cut down on so many vulnerabilities before a single line of code is even written.
And finally, Layer 4 is about governance. This is where we set the organizational guardrails. You absolutely should have an approved list of AI tools. You can set up usage tiers. Maybe you allow it for things like documentation scripts, but strictly forbid it for your most sensitive code like authentication or payment processing. And you have to have a way to audit and track where AI-assisted code has actually been committed into your code base.
I know what you might be thinking. This 4-layer strategy sounds like a lot of new work. But the goal isn't to create a whole new, heavy process. The goal is to seamlessly weave these defenses into the DevSecOps workflows you already have.
And this shows you exactly how that works. Before a developer even commits their code, you can use pre-commit hooks to run super fast, lightweight scans right on their machine. Then, in the CI/CD pipeline, you have that mandatory SAST quality gate we just talked about. And looking forward, you can start monitoring and tracking metrics specifically on vulnerabilities that came from AI-generated code. That helps you see the real impact and tune your policies over time.
Look, if you forget everything else we've talked about, please remember this next slide. This is it. This is the single core mindset shift that every security team, every development organization has to adopt to survive in the AI era.
Treat AI-generated code as untrusted input. It's really that simple. Think about it. You would never, ever go to some anonymous internet forum, copy a block of code, and paste it directly into your production application without scrutinizing every single line, right? Well, AI-generated code deserves that exact same level of suspicion. It's an external, unvetted dependency, and you have to treat it that way.
So as we wrap this up, the real question to ask yourself and your team is this: is your security posture actually ready for the AI era? Are your tools, your processes, and your policies really prepared to handle code being generated at a speed and a scale that we've just never seen before? Adopting the strategies we've walked through today is your first step toward being able to answer that question with a confident yes.